Welcome to qnawire.
So we're told there's a satellite that's orbiting 890 kilometers above the surface of the Earth. And so then in part A, we are asked to find then what the orbital speed of that satellite might be. So there's a couple of ways we could approach this. We could do energy, but I think probably looking at this from a force perspective will be a little bit quicker here. So because the satellite is moving in a circle, we know that it's subjected to a centripetal force, and the only force that's acting on it is the force of gravity. So it must be gravity that's making that centripetal force. So we say the force of gravity equals the centripetal force on the satellite, and the force of gravity will be gravitational constant times the mass of the Earth times the mass of the satellite, and then divided by r squared. And so r here is the total distance from the center of the Earth. So it's the radius of the Earth plus this 890 kilometers. And so that should equal the centripetal force, which always takes the form mv squared over r. So we can simplify this. One of these r's goes away, and as well as the mass of the satellite. So the mass of the satellite doesn't matter here. Any satellite of any weight would have to have the same speed to be orbiting at this height. And we can solve for the velocity then, and we get that it should be the square root of g mass of the Earth over r. And so r here is radius of the Earth plus 890 kilometers, so times 10 to the third meters. And we can evaluate that, and we should get that it is 7,410 meters per second. So that's the speed of the satellite. And then in part B, we're asked what the period will be in hours for the satellite. So for the period, we can say that the distance it has to travel is one circumference, so 2 pi r. So that's this circumference, not a very good circle here, going around the whole thing. And so again, r is radius of the Earth plus 890. So the distance it travels over its average velocity. So that'll just be 2 pi radius of the Earth plus 890 times 10 to the third meters, and divided by that velocity we just found, 7,410 meters per second. And we should find that that comes out to be 6,144 seconds. And then when we convert that to hours, we get that it's 1.71 hours.